Welcome back to part 2 of our series on multi-core fiber and space division multiplexing. Last time, we talked about the data explosion and why we need SDM. Today, we're going under the hood. How does MCF actually work and what makes it tick? We're diving deep into the engineering that makes petabit speeds possible. Hey again, it's Fiber Pro CA. If you missed part 1, check it out now. Link in the description. Today, we'll explore the engineering magic behind MCF and SDM. Ready? Let's geek out. At its heart, a multi-core fiber is like a bundle of tiny glass rods sharing one outer jacket. Each core is about 8 to 10 microns thick, thinner than a human hair, and designed to guide light independently. But keeping them independent is the real challenge. Enter the problem of crosstalk. Crosstalk occurs when signals bleed between cores, causing data errors. It's driven by evanescent waves, light that travels just outside the core's edge. To combat this, engineers space cores carefully, often 30-50 microns apart, and use special cladding materials to trap the light more effectively. Advanced designs use trench-assisted cladding, where a low index layer acts like a moat, reflecting light back into the core and slashing crosstalk levels. There are two main types of MCF for SDM: uncoupled and coupled. Each serves a different purpose in the global network. In uncoupled MCFs, cores are isolated to keep signals separate, ideal for long-distance transmission with low interference. This is like having multiple lanes on a highway with barriers. Recent 12-core designs from NTT achieve ultra-low crosstalk, enabling thousands of kilometers of transmission without signal degradation. This is the gold standard for global backbones. Coupled MCFs, on the other hand, allow intentional interaction. Randomly coupled ones mix modes to reduce differential delays, which is great for high-capacity submarine cables. Systematically coupled are more experimental, but promise even higher densities by treating the entire fiber as one superchannel. SDM ties it all together across these spatial paths. Combine it with WDM and you get massive capacity, like the 1 petabit per second over 7-core fiber demoed in 2024, scaling up to record highs in 2025. But MCF isn't the only SDM player. Few mode fibers, or FMFs, use a single larger core supporting multiple light modes, like different patterns of waves. FMFs can scale to 100 modes, but managing mode interference requires complex MIMO processing, massive digital math. MCFs often win for simplicity and lower crosstalk. Building MCF isn't easy. Designers must balance core count with diameter. Standard is 125 microns to fit existing infrastructure and avoid bending losses. The process starts with a preform, a giant glass log with the core pattern already inside. Techniques like vapor axial deposition, or VAD, ensure extreme purity. Then, it's drawn down a tower, melting at thousands of degrees to become the thin strand we use. Squeezing multiple cores into this process requires sub-micron precision. Advancements in 2025, like Litera's all-wave Flex 4X multi-core fiber, focus on flexibility and integration with AI-optimized networks that need high-density cabling. These fibers are specifically designed to handle the massive, bursty data loads of modern AI training clusters, where every microsecond of latency counts. Amplifiers are crucial too. Multi-core Erbium-Doped fiber amplifiers, or MCF-EDFAs, boost signals across all cores efficiently, cutting power use. By using one pump laser for many cores, we drastically reduce the energy footprint of the entire network, making the Internet of the future much greener. Challenges remain: higher manufacturing costs and splicing multiple cores precisely. If you're off by even a micron, the data can't jump between fibers. But solutions like fan-in, fan-out devices are emerging, allowing us to connect these advanced fibers to our current network hardware seamlessly. MCF and SDM are engineering marvels pushing boundaries. In Part 3, the finale, we'll see real-world applications and the future roadmap. Smash that like button. If you're excited for the future of fiber, subscribe and turn on notifications so you don't miss the conclusion. See you soon for the big finish. See you in the finale. Thanks for watching. Part 2 complete. Stay tuned for more from Fiber Pro CA.